In this video, I'm going to read the article from checkpoint 1 in case you don't want to read it for yourself. And I'm also going to give you the directions on how to do the rest of the checkpoint after the reading. So I'm going to skip this for now. I'm going to go to the article. And the article is titled, The Conservation of Matter During Physical and Chemical Changes. Matter makes up all visible objects in the universe, and it can neither be created nor destroyed, which we know already from our PFA. Water in this picture, it's saying water in 3 states. Water can exist in 3 different physical states, a gas, a liquid, and solid, all under natural conditions on Earth. Regardless of its physical state, they all have the same chemical composition, saying water is always made of 2 hydrogen atoms and 1 oxygen atom, whether it's ice, liquid, or gas like steam. Matter makes up everything visible in the known universe, from porta-potties to supernovas, and because matter is never created or destroyed, it cycles through our world. Atoms that were in a dinosaur millions of years ago and in stars billions of years before that may still be inside you today, since we can't create or destroy it. Matter is anything that has mass and takes up space. It includes molecules, atoms, fundamental particles, and any substance that these particles make up. Matter can change form through physical and chemical changes, but through any of these changes, matter is conserved. The same amount of matter exists before and after the change. None is created or destroyed, and this concept is called the law of conservation of mass, the biggest thing this article talks about. In a physical change, a substance's physical properties might change, but its chemical makeup does not. For example, with water, it's made up of 2 hydrogen atoms and 1 oxygen atom. Water is the only known substance on Earth that actually exists naturally in all 3 states. You can go somewhere on Earth and find water frozen as a solid, in ice as a liquid, which is all over the place, and even as a gas, which is evaporating all the time from lakes and rivers and oceans. To change between these states, water must undergo physical changes. When water freezes, it becomes hard and less dense, but it's still chemically the same, 2 hydrogens and 1 oxygen. There are the same number of water molecules before and after the change, and the chemical properties of water stay the same. To form water, however, hydrogen and oxygen atoms must undergo chemical changes, or for a chemical change to occur, atoms must either break bonds and/or form bonds. The addition or subtracting of atomic bonds changes the chemical properties of the substances involved. Both hydrogen and oxygen are diatomic, which means there's 2 of them, 2 hydrogens, 2 oxygens, that exist naturally. And they show what it looks like here, H2 and O2. In the right conditions and with enough energy, these diatomic bonds will break and the atoms will join to form water. Chemists write out this chemical reaction as, right here you see 2H2, meaning 2 hydrogens, plus O2, 1 oxygen, yield or make 2 water molecules, H2O. And the important thing is, look, 2 here and the little 2, you multiply those numbers, that means there's 4 hydrogen. Over here, we still have a 2 and a 2, so there's 4. This little 2 tells us 2 oxygen. This big 2 is for everything, so there's 2 oxygen. So it's super important to know, we start with 4 hydrogen, we end with 4 hydrogen. We start with 2 oxygen, we end with 2 oxygen, because we can't create or destroy matter. Now we rearranged it. These 2 hydrogen and oxygen are gases that you can breathe. Water is normally a liquid, so they change how they are, but it's still just moving stuff around, moving the molecules around. And basically, I just explained this, so I'm not going to read it. Ecosystems have many chemical and physical changes happening all at once, and matter is conserved in each and every one, no exceptions. Consider a stream flowing through a canyon. How many chemical and physical changes are happening at any given moment? Well, first, let's consider the water. For many canyon streams, the water comes from higher elevations and originates as snow. Of course, that's not where the water began. It's been cycled all over the world since Earth first had water. But in the context of the canyon stream, it began in the mountains as snow. The snow must undergo a physical change, melting, to join the stream. As the liquid water flows through the canyon, it may evaporate, which is another physical change, into water vapor. Water gives a really good, clear example how matter cycles through our world, changing forms but never disappearing. And this is just a big specific example of the water cycle. Next, consider the plants and algae living in and along the stream. In a process called photosynthesis, these organisms convert light energy from the sun into chemical energy stored in sugar. However, the light doesn't light energy doesn't produce the atoms that make up those sugars. That would break the law of conservation of mass. It simply provides energy for a chemical reaction to occur. The atoms come from carbon dioxide in the air, water in the soil, and then the energy from light allows those bonds to break apart, reform, and produce sugar and oxygen like we see here in this equation. So the plant takes carbon dioxide from the air, water from the ground and air. The light energy from the sun gives enough energy to break those molecules apart, move them around to make sugar and oxygen. But if you figured out how many carbons, oxygens, and hydrogens there are on this side of the equation, they'll be the same over here because the law of conservation of matter says we can't create or destroy matter. Matter is always conserved, which basically is what this paragraph said. When animals in and around the stream eat these plants, their bodies use the stored chemical energy to power their cells and move around. They use the nutrients in their food to grow and repair their bodies. The atoms for new cells must come from somewhere. Any food that enters an animal's body must either leave its body or become part of it. No atoms can be created or destroyed. So when an animal eats, some of the molecules and matter that comes in are rearranged and turned into things like ATP for energy. Some we don't need, they're wasteful, so we pee or poop them out. But nothing goes away. We either change it and use it, or we change it and get rid of it. Matter is also conserved during physical and chemical changes in the rock cycle. As a stream carves deeper into a canyon, the rocks of the canyon floor don't disappear. They're eroded by the stream and carried off in small bits called sediments. These sediments may settle at the bottom of a lake or pond at the end of the stream, building up in layers over time. So what they're saying so far is when water runs through like a canyon, it's breaking off little pieces of rock, it's carrying mud and leaves and dirt, and they get deposited or dropped off somewhere. And then more of it gets put on top and on top and on top, and eventually the weight of each additional layer here compacts or pushes the layers beneath it under so much pressure that it makes new sedimentary rocks. This is a physical change for the rock, and sometimes the rock may chemically change too, but the rock wasn't formed from nothing. It just was pushing together other rocks, so the rock matter is conserved, and the law of conservation of matter still holds true. The bottom line is matter cycles through the universe in many different forms. In any physical or chemical change, matter does not appear or disappear. Atoms created in the stars a very, very long time ago make up every living and non-living thing on Earth, even you. All the heavy elements other than hydrogen and helium are made from giant star explosions, and those atoms, or some of them, are in you. So you're technically made of some stardust. It's impossible to know how far and through what forms your atoms have traveled to make it to you, and it's impossible to know where they'll end up next. This isn't the whole story of matter, however. It's a story of visible matter. Scientists have learned that about 25% of the universe mass consists of something called dark matter, which is matter that can't be seen but can be detected through its gravitational effects. The exact nature of dark matter has yet to be determined. Another 70% of the universe is even more mysterious, called something called dark energy, which acts counter to gravity. So normal matter that we talked about in this article only makes up about 5% of the universe. And there's not much known about dark matter or dark energy. These things weren't even discovered when I was born, and that was 1976, but in the grand scheme of things, that's not that long ago, and they didn't even know this stuff was. All right, when you finish reading that, you're going to go back up to your boxes. This blue box is where you'll write your summary. Tell me what the article about. Remember, the main point of this article is the law of conservation of matter. Tell me what that is. Give me some examples. Put a quote in there so you can get an A, and you'll be good for your 4 or 5 sentences. Remember, though, grammar counts. Make sure you use spell check, capitalize your beginning of sentences, things like that. Gray box is 2 things that you liked about the article in complete sentences. Purple is 1 sentence telling me what you did not like. And then the blue is 1 sentence telling me why you would or would not recommend this article to a friend. Hope this helped.